Okay, now let's look at rational exponents. And the key to rational exponents is first to realize very clearly what an exponent is and what a root is. So let's look at exponents first. Exponents are pretty straightforward. If you say x to the fourth, that's just x times x times x times x. And 7 to the third is 7 times 7 times 7. 7 times 7 is 49. 49 times 7 is going to be 343. 5 to the fourth is simply 5 times 5 times 5 times 5. Y to the third, y times y times y. That's what an exponent is. Pretty straightforward. Now, let's think for a second about what a root is. So, most of us know square roots. The square root of 25 is 5. The reason square root of 25 is 5 is because 5 times 5 is 25. In the same way, the square root of 81 is 9 because 9 times 9 is 81. Now, you can also have the square root of 7. It's going to be a decimal, and we can't figure it out on our own, but we can still say that 7, the square root of 7, is going to be about 2.65. If you think about 3 times 3 is 9, 2 times 2 is 4, it kind of makes sense. So the square root of 7 exists even though it is a decimal. On the other hand, the square root of 100 doesn't exist. Now, it is true that you could use imaginary numbers. Whether you use imaginary numbers depends really on the context of the problem, and for what we're doing now, we're not going to do imaginary numbers. So that's square roots. Now, the way to think about square roots is you can almost imagine a tiny little 2 right there. We don't write it, but you can imagine, and that means the square root. And then we get to the idea of what a cube root is. A cube root is like a square root, but it's a cube root. So let's think about what a cube root is. A cube root of 8 means what number times itself again is equal to 8. And since 2 times 2 times 2 is 8, we say the cube root of 8 is 2. The cube root of 125 is going to be 5 because 5 times 5 times 5 is equal to 125. And the cube root of 1,000 in the same way is equal to 10. Now, one difference between cube roots and square roots is if you take the cube root of a minus 8, that's just minus 2. Because minus 2 times minus 2 times minus 2 is equal to negative times negative is a positive, and a positive times a negative is a negative. So that'll be a negative 8. So unlike square roots, where we said before that the square root of minus 100 does not exist, the cube root of minus 8 is just minus 2. This, by the way, works the same way for all even roots and all odd roots. So in the same way, we can say the fourth root of 11 exists, but the sixth root of minus 19 does not exist. And it's an easy way to do it. Every root, even root, works like square root. So square root of 11 exists, so fourth root of 11 exists. The sixth root of a negative number doesn't exist because the square root of a negative number doesn't exist. Odd roots, on the other hand, of any type, whether positive or minus, exists. So now we're ready to define what a rational exponent is. And the way that we define a rational exponent is we say x to the 5 over 3 is equal to the cube root of 5. I'm sorry. The way that we're going to say it is we're going to say x to the 5/3 is going to be the cube root of x raised to the 5th power. Or we can say it's x to the fifth, and it's the cube root of that. Let's look at another example for our definition. If we say x to the 4/5, the denominator is going to be the root. So that's the fifth root of x raised to the fourth power. So here's the thing to remember. Exponent. The exponent is going to be the numerator, and the root is going to be the denominator. Numerator, exponent, denominator, root. Root, denominator, exponent, numerator. That's the key. X to the 4/5, the fifth root of x raised to the fourth power. So that's the definition of rational exponents. In the following videos, we'll do problems of each type.